Hey guys, and good morning. Today we're going to talk about simple machines. So you have your agenda, obviously the bell ringer, and we're going to talk about the simple machines. Also, I want to emphasize to watch the last video posted, just in case you didn't, because it goes over the reverse engineering process. Okay. So just in case you didn't watch the last video because there was nothing really assigned that day and whatnot, take a gander at this and we should be all good. So I'm going to talk about your simple machines assignment. So this right here is your simple machines assignment. And one, you're going to actually watch this video that I'm making right now. And you're going to follow the directions on the document after you filled out the second part of the paper. So we're first going to kind of go over what is simple machines and kind of what they are. So I'm going to go here. Yeah, no, we'll just go from this way. All right. So simple machines. Now I will post also a video if I can find one that's good enough. I will also post another video on here about what simpler machines are so you can watch a video plus read this document. Now a simple machine, there's a couple of them. So there's lever, wheel and axle, pulley, and one second, I gotta plug in my computer. Where's my plug in for my computer? I'm running out, I'm running out, I'm running out of batteries. Ha 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 ha, no batteries. Minor technical difficulty. The brown cord's just the lamp, so pull it out. There you go. All right, now that we're all charging now. Okay, so as I was saying, we have levers, wheel and axle, pulley, inclined plane, wedge, and screw. So that's 6 simple machines. Now, this is something you kind of should have learned in middle school. So for some of you guys, this is probably just a refresher course. I'm going to go over this right now with you guys, going through them just so kind of help you remember. So a lever is a board or bar that rests on a turning point called a fulcrum. The closer the object is to the fulcrum, the easier it is to move. So it's used for pushing, pulling, or lifting things. Something like a bottle opener or a crowbar would be something you can use, that everyday item. Well, maybe not the crowbar. Um, and an example could be a seesaw. So in this case of the seesaw, if you kind of noticed, this person is farther away than this person. And that is because this person is smaller. So in order for her to lift the bigger person, she's got to be farther away from the middle section of the fulcrum. Now, the lever is probably one of those things that we've used. If you used a hammer, you've used the lever, okay? If you used, trying to think, If you ever done catapult designs, you've used a lever, so on and so forth. So then we have wheel and axle. The axle is a rod that goes through the wheel. The axle allows the wheel to turn, moving or turning things more easily. Things like roller skates, wagons, doorknobs, or gears. So those would be an example of a wheel and axle. Think of a steering wheel in a car. Think of the car wheels themselves. A fan technically is a wheel and axle. Um, hmm. Basically anything with a wheel or turns and has a center point in which it's turning from is a wheel and axle. Then you have a pulley. Pulleys are made up of a wheel and a rope that fits on the groove of a wheel. One part of the rope is attached to the load. When you pull on one side of the rope, the wheel turns and the load moves. Okay, this helps with lifting heavy objects by changing the direction or the amount of force needed to be on there. Flagpoles, sailboats, blinds, cranes, all use the pulley simple machine mechanism. So you can kind of see right here an example of someone lifting. It kind of looks like apples, so I don't know why they would be lifting that, but and depending on how many pulleys you have here depends on how much actual force you as the person need to put on that object. So the more pulleys there are, the less force you have to pull something that's super heavy. And then you have an inclined plane. An inclined plane is a flat surface that is higher on one end than the other. This is moving heavy objects up or down, ramps, slanted roads, or slides. Okay, and a slide, you would be going down normally, not going up. UPS people went, or not UPS people, what's that moving company called? I can't remember. Anyways, when people are moving like boxes or heavy things, they normally have a ramp. If you've ever watched people unloading at Dollar General or at the gas stations when they have the sodas and stuff, they have like an inclined plane that they come down with their boxes and wares. Then you have a wedge. A wedge is a simple machine used to push two objects apart. A wedge is made up of two inclined planes. These planes meet and form a sharp edge, cutting or splitting other objects, knives, axes, forks, and nails. Okay, so an axe is probably the most easy one to reference here because when you're splitting wood, you're using the wedge and the force you're giving the wedge to split the wood apart. Another would be a knife cutting something. In this case, they're showing bread, but even something as simple as a steak, vegetables, the anything where you're cutting would be considered a wedge. And then you have a screw. A screw is actually an inclined plane that winds around itself, lowering and raising things or holding objects together. Jar lids, light bulbs, clamps, wrenches, and then spiral staircases would all be considered a screw mechanism. A screw is a screw. Let's put it that way. So something that you screw into the wall, like a screw, is a simple machine. Now, for this activity, you're using the grid below to list each of the simple machines, what it is used for, and draw an example of each. Some cells have been filled in for you. Okay, so what you're going to do is over here, you're going to define the simple machine, say what it's used for, and give an example, which is right here. So what you're going to have to do for this assignment is you're basically taking what's up here and reapplying it down here with examples. Now, for some reason, I can't make this open correctly in Google. So what you're going to do is you're going to create a document. And in that document, you're going to go to Insert Table, and we had 3 rows. Yes, I believe 3 rows. 6 objects. We need a header, so we're going to go 7. And so right here, okay, we have 3. We have the simple machine, used for, and then example. All right, and some of these are filled out. So I'm going to go to my document. I'm going to put simple machine, used for, and then my example. Now, these examples can be found on the internet. That's why I'm saying you can do it this way. Or you can print this out and sketch your examples, excuse me, here. Either way works. So I'm going to give Waha, I'm going to give the example for wedge, which is down here. So that is the second one from the bottom. So wedge, and then used for. So what is it used for? So wedged is used for cutting things and splitting things apart. Okay, that's more or less what it's used for. And then what I'm going to do is I'm going to go over here and I'm going to actually insert a image. So I have some images that I can use on my thing. And there you go. And that is it. So that's all I'm asking for you guys to do for here is find an image. Again, it can be on the internet, whatever have you. And you're just going to put wedge, what's it used for, and then an example. Pretty simple. If you guys have any questions, please email me. And again, you can do this one of 2 ways. You can either A, print out this sheet, or if you were given this sheet by the school, you can just use the sheet and then take a picture of it and put it on here, or you can create a document and put it on here as well. All right, that's all I got for you. See you in the next video. Bye.